This is the Mars Tri-Rover that I made. It has many parts, such as the camera, generator, solar panels, acquisition arm, mobility system, wheels, and wheel hub. The wheels on the Mars rover move forwards and backwards and are attached to the hub using a shaft and hole system with a basic size of 12 millimeters. The hole has a transition tolerance of K7, and the shaft has a tolerance of H6. The arm is attached to the shoulder joint and allows for the arm to move vertically. The joints of the arm are all attached using a shaft and hole system with a diameter of 12 millimeters. The tolerances are also a transition of H9 for the hole and D9 for the shaft. The mobility system also has a wide range of movement, which could easily allow it to traverse rough terrain. The right and left suspension systems could also turn independently from each other, allowing for a greater degree of motion. The front and back wheels also have their own joint system to allow the rover to freely turn. This would make it easier for the rover to make sharp turns and rotate. The shoulder has up to 140-degree range of motion and allows the arm to rotate horizontally. The shoulder joint is attached to the chassis by a shaft with basic size of 30 millimeters in diameter. The hole has a tolerance of H9 and the shaft has a tolerance of D9. The joints of the arm are attached using a shaft and hole system with a diameter of 12 millimeters. The hole has a loose running fit of tolerance H9 and the shaft has a tolerance of D9. This allows the arm to move vertically and could grab as low as the ground and as high as the helm and as high as the camera. The fingers are attached using a shaft and hole system of 10 millimeters in diameter with a loose running fit of H9 tolerance for the hole and D9 tolerance for the shaft. The finger, the hands of the arm have multiple joints and could allow it to move its fingers to easily grab objects. The base of the camera uses a pin-like system in order to rotate the camera and also move it vertically. The hole and shaft of the base have a base diameter of 60 millimeters in diameter and have a clearance fit of E9 for the hole and E8 for the shaft. The camera is attached to the base using a hole and shaft system with a diameter of 12 millimeters. It has a loose running fit of tolerance H9 for the hole and D9 tolerance for the shaft. The This fit helps the camera rotate up and down. The solar panels are attached to the hinges by a pin with a diameter of 40 millimeters. The hole on the hinges of the solar panels have a transition tolerance of H8, and the pins on the chassis have a tolerance of N6.